Okay, geometry section 11.5. I only have just a bit of information here. These are formulas you should be familiar with. The circumference of a circle is 2 pi times the radius. It can also be written as pi times the diameter. Okay, and the area is pi r squared. Now sometimes you'll be told to keep pi. That means pi is still in your answer. Sometimes you'll be told to substitute using 22/7, sometimes 3.14. Always do the one that is required of you or your answer won't be correct. So be paying attention to the instructions. And the new idea that we have here is that pi is equal to the circumference over the diameter. And I've given you a project to test that several times. Told you to find a lid in your kitchen or somewhere else. It can be a coffee can lid, it can be a lid for a large bowl. Try to find some different sizes and experiment with this. Find the circumference, find the diameter, do the math, and it should closely approximate 3.14 every time. So try that out and send me your results. All right, so that pretty much covers everything you need for 11.5. So the main focus here is going to be on 11.6, and this will build off of 11.5. We'll still use these same ideas. All right, so if you'll look on page 452, arc lengths and arc sectors, they like to make it look a little more complicated than it is here. If we look at a circle, okay, the last section mentioned that the circumference is basically the perimeter, but if we look here by putting an inscribed angle, or sorry, that's not right, a central angle because it's at the center, and it marks off an arc. Now up until now we have known the measure of the arc, say to be 50 degrees, and that corresponds to the measure of the angle. What we're going to be looking for here in 11.6 is actually the length of the arc. So that would be like if I held up a piece of yarn, if I traced it exactly, and then I pulled it out and I measured it. Right, so this is what the formula is going to help us with, and it's also going to look at the area of a sector. Well, now if we think about that, the arc length is basically a portion of the circumference. We're just going to abbreviate here, circumference, and a sector is an area. It's part of the entire area of the circle. Okay, so if you can look at it like this, you have formulas in the lavender box, all right, and they're accurate, they're good formulas, but rather than just memorizing a list of values, think about the idea here. So let's use 50 degrees as an example and run through it. Now make sure you've already read it and look through the examples, look through what I've sent you. This is just a supplement so that you can see what we're doing here. So if I'm told that the radius of the circle is 3, that means every radii of the circle would be 3, and that I have a 50-degree arc here, we can determine the arc length using their formula, which is basically we want to find out what portion of the circumference we have, and then we want to multiply it by the actual circumference formula, which is, in this case, what we would want since we know the radius, 2 pi r. Okay, now the portion of the circumference that this is 50 degrees for this little bitty arc. What's the entire circumference of the circle? It's going to be 360 degrees. So 50 over 360 gives me the fractional part of the circumference that I'm actually talking about. And then I want to multiply by 2 pi r. 2 pi is pi, but r is the radius of 3. All right, then we can just work the math. Let's kill off some zeros there. We're going to have 5 over 36 times 6 pi. 6's are going to cancel here, giving me 5, 6 pi. Now, if that's good, if that's what the formula asks for, we'll keep 5, 6 pi. Maybe they told you to use 22/7 as an estimate, in which case I would say 5, 6 times 22/7, replacing that for my pi, and we would need to do some cancellation here. 55 over 21 and think about whether or not that's reduced. I think we're good there, and we would keep this. So make sure that you look at what they're asking for. If we wanted to use 3.14, then at this point we would simply multiply 5/6 times 3.14 and get a decimal answer. Okay, so just looking at it one more time, let's use a different value. Instead of 50 degrees, what's my next one I've got? Let's do 140 degrees. We'll just choose one here. Okay, so again, if I want to find the arc length, that's what we're looking for, the arc length. And it's equal to the portion of the circumference that we're looking at times the circumference formula. I already had that written there. Okay, well, I guess it didn't hurt me too much to do it again. The portion of the circumference, then, now we're using 140 degrees out of 360 degrees. We're still multiplying by the formula for the circumference, 2 pi r, and we didn't change our radius, it's 3. You want to be careful with that. If the radius changes, then we're going to do that. Again, we're going to kill off some zeros. We have even numbers here, so we can reduce this to, what, 7/18. Am I getting probably too low for my camera person here? 6 pi. 6 is going to reduce here, so I'm basically going to have 7/3 pi, or whatever equivalent that we're looking for there. And you're going to have to check my math. I'm doing it kind of fast without a calculator, so hopefully we're doing all right here. Now, this is to find arc length. And we have two ideas in this section in 11.6. We're going to find arc length, but we're also going to find the area of the sector. The sector is basically the piece of pie that we're looking at. Let's go back to 50 degrees and we'll look at that as well. Okay, instead of finding the arc length, now we want to find the area of this whole sector. Works just the same way. I'm still looking at a sector that is a portion of my whole circle. So I have 50 degrees out of 360 degrees, but since I'm looking at the sector, I'm using the area formula because sector is a part of the area. So we're using pi r squared, and since r is 3, we want to put 9 in there. Okay, I don't think that's going to reduce for me. 5/36 times pi times 9, and 3 goes, oh, actually 9 goes into the whole thing, so we're going to have 5/4 pi here. Same thing would work if we did the 140 like before. Again, we're looking at sectors, so sector is a portion of the area. We would put our 140 in here. We would reduce appropriately. We would multiply by pi times 9 and do the reduction. Okay, so arc length, portion of the circumference multiplied by the circumference. Sector is the portion of the whole, the area of the circle times the area of the circle. Okay. Now they're going to introduce one more idea on page 453 at the top. In this particular case, no longer do we want to find the sector of the circle, but we want to find this piece right here. Okay, and they reference that as the portion that's bounded by arc AB and segment or chord AB. So we just want to find this. Now, in order to do that, we're going to find the area of the whole sector, just like we talked about a minute ago. And then we're going to subtract off the area of this triangle. Now, it's always going to be an isosceles triangle, and we've already gone over how to work that. Sometimes you may have, say, 36 pi minus 4. 36 pi and 4 do not go together unless we're using decimals, so sometimes keep that. So study the example there. You may find the area of this triangle. If it's a right triangle, you can use the Pythagorean theorem to find the legs and do 1/2 base times height. You may have to draw your altitude because it is isosceles and work it out that way. But we're going to find the sector using the method we just learned and subtract off the area of the triangle. Okay? But again, if it gives you some trouble, text me or contact me, I guess, through my schoolworks, and we'll see what we can do from there. All right, thank you.